basic laws of continuity. Okay, so these are kind of going to be the same as the basic limit laws that we've learned, but this time instead we're dealing with continuity as opposed to limits. So our assumption is going to be if f of x and g of x are continuous, I'll just abbreviate so you guys don't have to watch me write out the word continuous every single time. So are continuous at x equals c, the following are also continuous at x equals c. Okay, and I'll just write a little list here. And like I said, you're probably going to recognize it from our basic limit laws that we've also learned. Alright, so I'll put a little colon there. Alright, because I'm going to list things. So the first one that's going to be continuous as well is f of x plus g of x. Okay, so that function is going to be continuous. This is kind of mirroring the sum law, remember? Number 2 is, for number 1, I'll just add in that this is also true, f of x minus g of x, just because we have, this minus sign basically comes from adding the opposite, or the negative one of the second function. But anyways, so that's just a little side note there. Number 2 is that k times f of x is going to also be continuous for any constant k, okay? Okay, constant k, alright? And then number 3, this is going to mirror our, this is going to resemble our product law. So this will be f of x times g of x. Alright, and our last one I'll just write over here. This is going to be number 4. This is f of x divided by g of x. And whenever you're dividing things, we also have to have the condition that g of x cannot equal 0. Anything on the bottom can equal 0 because we want to keep everything defined and nice. Okay, so now we'll go on to polynomial and rational functions. Okay, so as far as polynomials, those just mean anytime you have so polynomial, this is a sum of continuous functions that look like this. So I'll write down an example. Alright, so let's say we have polynomial. So some function of x is equal to an, so this is just a coefficient, just some constant number, okay, times x to the n power. So x to some power plus a sub n minus 1 times x to the n minus 1 plus ... and we'll just keep going until we get to a 1 times x to the 1 plus sorry, that's not an a. I was thinking a, but I wrote an x. A sub 0, there we go. A sub 0 times x to the 0 power. So this is just going to be a 1, and this will just be a constant. Okay, so anyways, this is what a polynomial looks like. An example would be something simple, like f of x is equal to x to the third, in which case the a sub 3 would be a 1, right? Plus, I don't know, x to the first, 2x to the 1 power, and then minus 3. So just something like that, any polynomial. So the purpose here is saying that the sum of continuous functions, because each of these terms are continuous, okay? All of these terms are continuous by themselves. So that means that the sum of them, according to the sum law, the entire function, so p of x, must be continuous. Must be continuous, okay? Also, if we were to have that, we also have like a q of x. So this is, let's say q of x is another polynomial. Okay, so this is a polynomial here. Nomial. So if we have p of x being a polynomial and q of x as a polynomial, by law number 4, so the quotient law for continuity, then p of x divided by q of x, so a polynomial which is a continuous function, divided by another polynomial which is also a continuous function, must be, I'll make it an arrow, this must also be continuous, provided that, that q of well, we'll say it's continuous at c, at x equals c, because we always have to say we're considering continuity at a point. So anyways, it's continuous at x equals c, given that q of c is not equal to 0. Because remember, we want to keep this quantity here defined, so we can't have a 0 on the bottom there. Okay, so that's it about polynomials. And now let's go on to more continuous basic functions. Continuous basic functions. Okay, so some more would be, I'm just going to give you a little list here, so you'll be able to recognize them when you see them in problems and say, okay, so those are continuous, I know that. So y equals x to the 1 over n, and this is the same thing as saying the nth root of x, okay? So this is going to be continuous. Something else that will be continuous are the basic trigonometric functions, so sine of x and as well as cosine of x, okay? So those are the wave-looking ones. We also have y equals b to the x power. That's a continuous function. It's kind of basic, as long as our b is greater than 0. Well, this one as well as these kind of come in pairs here. So log, so the logarithm of, with base b of x. So these two here, so both of these, okay, these are as long as b is greater than 0 and b is not equal to 1, okay. So those are just the limiting conditions there for those last two only, right? These ones are free to go. They're continuous at all times. But for this, then those conditions apply. Okay, and let's go into more detail about the trigonometric functions. So let's go beyond sine x and cosine x. And so we're going to say that tangent x, so tangent x is formed using sine x over cosine x, right? So these ones, according to the quotient law, or law number 4, for continuity, this tangent x should be continuous at all points, except for when cosine x, so this is continuous, well, tangent of x, sorry, got a lot of arrows here, so continuous except except for when cosine x is equal to 0, then it has an infinite discontinuity. Discontinuity, okay? So when does cosine x equal 0? That is when x is equal to plus or minus pi over 2. That would be 90 degrees, plus or minus 90 degrees, plus or minus 3 pi over 2, and etc. and so on. So when you're at the top of the unit circle or the bottom of the unit circle. Okay, let's see, what else do we have? So secant x, let's deal with that. So secant x is the same as 1 over cosine x. And this is actually going to have the same conditions here because we have this cosine x on the bottom. So we can just extend these conditions to secant x as well. Okay, so this still applies. It has an infinite discontinuity, both tangent and secant x, when x is equal to plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, etc., etc. Okay, so let's look at another set of trigonometric functions. So let's say we have cotangent x. So this would be given by the same thing as tangent but flipped. So then we have cosine x over sine x. And I'll throw in another one, cosecant x, that's equal to 1 over sine x. So see how here, this pair of trigonometric functions both have sine x on the bottom. So this is going to be continuous except these are going to have infinite discontinuities. So infinitely discontinuous at the following points when sine of x is equal to 0. So when does that occur? That's when x is equal to 0, plus or minus 2 pi, well, I'll just go with pi first of all, plus or minus pi, plus or minus 2 pi, and etc., etc., etc. Right? So when it's all the way to the right of the unit circle or all the way to the left at 180 degrees. Okay? So that's basically it for the trigonometric functions, and now we'll go on to a new topic called inverse continuity.